Happy morning, students! I am Teacher Ann, your grade 10 science teacher. Before we proceed in our discussion, let us have a review regarding our past lesson. I have prepared a game entitled Wikarambulan the Science Edition. All you need to do is you're going to guess the following combined words that correspond to a specific scientific terminology. Example, soul, lotion. The correct answer is solution. Okay, let's start. You have learned in our previous discussion that gas is one of the phases of matter. It has no definite shape and size, and it can be compressed easily. We also talk about the properties of gases, which includes mass, volume, temperature, and pressure. Can someone recall what is mass? Very good. The amount of gas or its mass could be expressed in moles or grams, and the mass of gases is negligible. How about volume? The volume of a gas is the amount of space occupied by the gases. Gases have the tendency to occupy all the spaces of the container that they are confined. The common units used in expressing the volume of a gas are liter, milliliter, cubic meter, cubic centimeter, centiliter. Next, we have pressure. Can you describe pressure? Pressure is the average effect of the forces of the colliding molecules. It can be measured in atm or atmosphere, torr, millimeter mercury, and Pascal. The last one, we have temperature. The temperature of a gas is measure of the hotness or coldness of an object. It is proportional to the average kinetic energy of its molecules. When we say kinetic energy, we are pertaining to the movement of molecules. It can be measured in Celsius or Kelvin. How can we convert degrees Celsius to Kelvin? So just add 273.15. Like for example, the given is 0 degrees Celsius. So you need to add 273.15. So the answer is 273.15 Kelvin. Is it clear? Okay, next. I have here another game for you entitled 4 Picks 1 Word. You're going to analyze the 4 given pictures and give one word that best describes the 4 pictures. Let's start. Come up with relationship, pressure, volume, and temperature. What we are going to learn for today is all about the relationship between pressure and volume at constant temperature, which is also known as Boyle's law. But before that, let us have an activity. Your activity is entitled The Fantastic Balloon. What are the objectives of this activity? First is to investigate the relationship between pressure and volume at constant temperature. Second, relate the concept of Boyle's law in real-life situation. The last one, solve a problem involving pressure and volume. For the materials needed, we have 2 pieces balloon, plastic bottle, tape, and scissors. For the procedures, number 1, using the scissors, cut off the bottom of the bottle. Be careful in using the scissors. Number 2, take one balloon and put it inside the bottle. Fold the bottom of the balloon around the rim of the bottle so the balloon hangs from the top. Number 3, tie a knot at the end of the remaining balloon. And then, cut the large part of the balloon in half horizontally. Using the balloon half with the knot, stretch the open end over the bottom of the bottle. It should be look like this. You're going to tape it to secure it properly. The next procedure, gently pull down on the balloon from the net. Observe what happened. And then, release the balloon with the net. Observe what happened. Based on your observations, answer the following guide questions. The first question, what have you noticed when I pull down on the balloon? Second question, what happens when I release the balloon? Let's answer the first question. What have you noticed when I pull down on the balloon? Very good. It becomes bigger. How about its volume? The volume increases. How about its pressure? the pressure decreases. Next, for the second question, what happens when I release the balloon? The balloon becomes smaller. What about the volume? Its volume decreases. How about the pressure? Its pressure increases. Very good. We can relate this activity to your respiratory system. Try to inhale and exhale. Pulling the rubber balloon represents inhaling. As you inhale, the lung cavity expands, causing the pressure inside the lungs to decrease and becomes lower than the outside pressure. As a result, air flows from the higher pressure area, which is outside the body, into the lungs. Exhaling is the opposite process. When you release the rubber, which represents the diaphragm, the balloon representing the lungs decreases in volume. This phenomenon happens during exhaling. When the diaphragm contracts as you exhale, it results to a decrease in the lung volume, increasing the pressure inside the chest cavity and causing air to flow out of the lungs. Now, let's talk about Boyle's law. Boyle's law states that the volume of a fixed amount of gas is inversely proportional to its pressure at constant temperature. In mathematics, when we say inversely proportional, if one variable increases, the other variable decreases. So if the volume increases, the pressure decreases, or vice versa. If the volume decreases, the pressure increases. The relationship between the volume and pressure of gases at constant temperature was first stated by Robert Boyle during the 16th century. He performed an experiment wherein he trapped a fixed amount of air in the J-tube. He changed the pressure and controlled the temperature, and then he observed its effect to the volume of the air inside the J-tube. He found out that as the pressure increases, the volume decreases. He finally concluded that the volume of a fixed amount of gas is inversely proportional to its pressure at constant temperature. Similarly, this is what you observe on our activity. Gas particles have a weak intermolecular force of attraction. Hence, they move as far as possible from each other. They have the tendency to occupy all the spaces they are contained in. If the pressure increases, the volume will be decreased, forcing the gas particles to move closer to one another. And this law can be expressed mathematically as P sub 1 multiplied by V sub 1 is equals to P sub 2 multiplied by V sub 2, where P sub 1 is the initial pressure, V sub 1 is the initial volume, P sub 2 is the final pressure, V sub 2 is the final volume. Let us have a sample problem. The inflated balloon that slipped from the hand of friend has a volume of 0.50 liter at sea level, which is 1 atmosphere, and it reached a height of approximately 8 km, where the atmospheric pressure is approximately 0.33 atm or atmosphere. Assuming that the temperature is constant, compute for the final volume of the balloon. So what are the given? Our V sub 1 or initial volume is 0.50 liter. Our P sub 1 or initial pressure is 1 atm or 1 atmosphere. Our P sub 2 is 0.33 atm or atmosphere. So we are looking for the final volume. So our formula would be P sub 1 multiplied by V sub 1 is equals to P sub 2 multiplied by V sub 2. For this solution, P1 V1 is equals to P2 V2. We are looking for V2. Therefore, we will divide both sides by P2. Cancel. So our formula would be V2 is equals to P1 V1 over P2. Substitute the given. P1 is 1.0 ATM multiplied by V1, which is 0.50 liter, divided by P2, which is 0.33 ATM. 1 times 0.50 liter, the answer is 0.5, divided by 0.33. Cancel ATM. 0.5 divided by 0.33, the answer is 1.5 liter. So our V2 is 1.5 liter. Now it's your turn. Solve the given problem. A cylinder of oxygen for medical use contains 34.5 liter of oxygen at a pressure of 400 atm. What is the pressure when the volume is 100 liter at the same temperature? You need to write the given, formula, solution, and answer. Now, let's check your answer. What are the given on our problem? Our initial pressure is 400 atm. Our initial volume is 34.5 liter. Our final volume is 100 liter. Unknown is the final pressure. Our formula is P1 V1 is equals to P2 V2. For our solution, P1 V1 is equals to P2 V2. We are looking for the final pressure. Therefore, we will divide both sides by V2. V2. Cancel. Our formula would be P2 is equals to P1 V1 over V2. Substitute the given. Our P1 is 400 atm multiplied by our V1, which is 34.5 liter, divided by our V2, which is 100 liter. 400 multiplied by 34.5, we have 13,000 800 divided by 100. Cancel liter, cancel liter. So 13,800 divided by 100, RP2 is 138 atm or atmosphere. Great job! It seems that you really understand our topic. For your assignment, give at least 5 applications of Boyle's law in our daily living. That's all for today's learning session. I hope you've learned something today. Good day!